Throughout its entire history, humanity has been obsessed with the same fundamental, almost sacred dream: to break away from the ground and achieve true freedom in the sky. For centuries we have looked upward, envying birds whose wings seemed like nature's highest gift, and step by step, through blood, mistakes, and titanic effort, tried to replicate that gift. The evolution of our engineering thinking is astonishing. From fragile wooden gliders and early, barely controllable parachute jumps to supersonic passenger airliners and heavy military fighter jets. But if we look at it objectively and honestly, has this progress answered our deepest inner demand? Unfortunately, no. The modern person, when buying a plane ticket, is not truly flying in the sense a bird does. They sit inside a closed metal capsule, look through a tiny window frame, and drink coffee while a computer guides a multi-ton machine through the clouds. This is movement through space. This is a triumph of logistics, but it is not flight. An airplane completely isolates us from the sky. It does not transmit the feeling of wind, nor that primal sensation of your own body mastering air currents. Even extreme activities like parachute jumping or wingsuit flying are only prolonged, albeit controlled, falls limited by the grammar of gravity and by a few minutes before the canopy opens. Humanity has remained a prisoner of the ground, never fully able to experience what it truly means to fly. Of course, the industry did not stand still. In recent years, a number of ambitious technology companies have come into the spotlight, among which the British Gravity Industries led by Richard Browning stands out as a clear leader. They have created something that just yesterday seemed like science fiction: full jet-powered flying suits turning a human into something like Iron Man from Marvel Comics. Their systems, producing more than 1,000 horsepower through miniature jet engines on the arms and back, are already being actively tested by elite units of the Royal Marines and rescue services in hard-to-reach mountainous terrain. But let us be honest, the current versions of these suits are far from becoming everyday reality for billions of people. They are extremely heavy, require immense physical training and phenomenal balance, run on conventional aviation kerosene, are unbearably loud, and, most importantly, their autonomous flight time is limited to a mere 5 to 10 minutes. This is an amazing attraction and a niche tool for special forces, but not personal transportation of the future. However, we did not decide to make this video in order to once again melancholically reflect on the unattainability of true freedom and technological dead ends. Quite the opposite. Right now, before our eyes, behind the scenes of the global technology market, events are unfolding that prove that in the near future, the possibility of full-fledged, accessible, and safe personal flight for humanity will not only appear, it will become the new normal. And these are not empty words, not futuristic fantasies, and not clickbait. The reason for such tectonic shifts in the media landscape and expert community was the monumental news coming from Wall Street. The world's leading technology giant, the manufacturer of the most advanced reusable rockets, Elon Musk's company SpaceX, has officially gone public in an IPO, carrying out the largest initial public offering in human history. This historic event not only cemented Musk's dominance in the space industry, but also officially made him the first trillionaire in human history, as he controls about half of all company shares. SpaceX raised colossal, unprecedented funding, tens of billions of dollars in live cash, which, according to official statements, will be directed towards scaling the global high-speed internet satellite network Starlink, deploying orbital data centers for artificial intelligence, and accelerating the Starship program for the colonization of Mars. However, the most intriguing, sensational, and truly explosive fact emerged literally days ago. Reputable financial media outlets, including Bloomberg and Financial Times, citing their own high-level sources and insiders within Silicon Valley, shook the information space with news that SpaceX leadership and the top management of Gravity Industries have begun exploring potential strategic cooperation. At this stage, if the reports are to be believed, the discussion is limited strictly to closed preliminary talks and analysis of technological compatibility. Official representatives of both sides are either silent or issuing standard vague statements. But independent analysts unanimously argue that even the existence of such rumors represents a tectonic shift for the entire global transport industry. Because if these giants truly join forces and begin joint work on a next-generation commercial personal flight device, what emerges from the intersection of their capabilities would be nothing short of a nuclear combination. On one side, Gravity Industries with its unique patents in human flight ergonomics, integration of control systems with natural human biomechanics, and experience working with 3D-printed composite polymers. On the other side, SpaceX with its limitless financial resources, the world's best rocket engineers, access to cutting-edge alloys, and most importantly, technologies for engine miniaturization and artificial intelligence systems. So what might their potential collaboration and resulting product look like? Experts suggest a shift away from noisy and dangerous kerosene turbines toward a fundamentally new architecture, the so-called Gravity E-suit, a fully electric or hybrid suit. The main problem has always been battery energy density. But SpaceX, closely connected to Tesla's automotive developments and space energy systems, has access to secret solid-state battery technologies and ultralight fuel cells. Insiders hint that the new suit could be based on micro-rotating detonation engines or high-efficiency plasma microaccelerators adapted for operation in dense atmospheric layers. Visually, it would no longer be a bulky backpack with heavy arm-mounted thrusters. The SpaceX Gravity collaboration is aiming to create a lightweight anatomical exosuit made of carbon fiber and flexible graphene plates, worn like a tight athletic bodysuit. Control would be completely transformed. Instead of supporting body weight with arm strength like Richard Browning does, the user would be protected by a powered exoskeleton frame. An integrated SpaceX neural network, trained on millions of hours of flight simulations, would read the user's micro-muscle movements, balance, and head tilt in real time and automatically adjust the thrust vector of hundreds of micro-nozzles distributed across the suit. The person would simply lean forward and fly, spread their arms, and bank into a turn, while the computer fully eliminates the risk of stall or loss of control due to sudden wind gusts. The projected technical specifications of such a device are said to be revolutionary. Estimated speed of a production model would range from 150 to 250 kilometers per hour, while flight altitude for safety reasons would be software limited to 300 to 500 meters, although the technical ceiling would be significantly higher. But most importantly, thanks to new energy sources, flight endurance would increase from 5 minutes to a full 1.5 to 2 hours, transforming the suit from an expensive toy into a genuine means of transportation. When such technologies could potentially become a reality for the commercial market, leading analysts at Morgan Stanley and Goldman Sachs, assessing the pace at which SpaceX is deploying its raised capital, agree that the first working prototype of a joint production project could be presented to the general public within 3 to 4 years. The start of small-scale production and the first closed sales for technology enthusiasts and government agencies are forecast around 2031 to 2032. Of course, the key question for most people will be price. In the early stages, as is always the case with breakthrough technologies, the cost of the suit will be extremely high. According to insider estimates, the first production units could cost around $350,000 to $500,000, comparable to a premium supercar. However, Elon Musk's business model has always been based on gradual cost reduction through mass production. Following the analogy with electric vehicles, 7 to 10 years after the launch of the first model, meaning closer to the end of the 2030s, the market could see a kind of Model 3 equivalent in the world of flying suits, a mass-market civilian version priced at around $40,000 to $50,000, available through credit or long-term leasing to the middle class. Moreover, flight-sharing services and tourism hubs are expected to become extremely popular, where such a suit could be rented for the weekend. The emergence of such a product would not just change the world, it would fundamentally rewrite human civilization, triggering an infrastructural and social revolution. Imagine how our understanding of travel and daily logistics would change. The concept of traffic jams would disappear forever. People would no longer spend hours stuck on bridges and interchanges. A commute from a suburban home that once took 2 hours by car could take 15 minutes in a straight line through the air. The very architecture of cities would change. Urban planning would shift focus from road surfaces to building rooftops, which would become flight terminals, parking replacements, and charging stations. A large-scale decentralization of megacities would begin. Why live in a crowded city center if you could own a house in a scenic forest or by a lake 150 kilometers away and fly there faster than taking the metro? Tourism would become completely different. People would be able to explore canyons, mountains, river valleys, and inaccessible jungles while literally gliding above them at bird's-eye level with no environmental damage. But of course, such a radical technological leap carries enormous, unprecedented risks, and these will become the main stumbling block. The first and most powerful barrier against early enthusiasm will be regulatory risks and the position of governments worldwide. The Federal Aviation Administration and similar agencies in Europe and Asia will be alarmed by the prospect of millions of uncontrolled flyers in urban airspace. A completely new legal framework will need to be built from scratch. Special air corridors will have to be designated. Automatic collision avoidance systems will need to be developed, and pilots will likely require strict licensing. Intelligence agencies and police forces will raise security concerns. How do you control borders if anyone in a suit can fly over a fence? How do you prevent intrusions into private property, protected sites, or government rooftops? Regulators will likely require strict software-based restrictions, so-called no-fly zones embedded into the suit's GPS module, physically blocking propulsion systems when approaching airports, military bases, or nuclear power plants. The second category of threats is purely technical and physical. Unlike a car, where an engine failure simply leaves you stopped on the roadside, in a flying suit, any major system failure or battery depletion at 200 meters altitude would result in a guaranteed fatal outcome. Engineers will have to implement full redundancy across all critical systems. If 3 micro-rotors fail, the remaining 40 must still be able to keep the suit stable and bring it down safely to the ground. A mandatory safety feature will be an integrated ultra-fast emergency parachute system with a pyrotechnic deployment charge, capable of deploying even at an altitude of just 10 meters above the ground, as well as airbags that instantly inflate around the pilot in case of dangerous proximity to the ground or buildings. In addition, the human factor cannot be ignored. Panic attacks at altitude, reckless flying behavior, collisions with birds, power lines, or delivery drones. In summary, it can be stated with confidence: will such a product be a revolution? Absolutely yes. It would represent the greatest civilizational shift since the invention of the wheel or the internal combustion engine. The potential alliance between Elon Musk's trillion-dollar SpaceX empire and the pioneers of personal aviation at Gravity Industries is not just a commercial deal. It is a historical response to that ancient primal call that once made our ancestors look at birds with envy. And although years of harsh testing, intense regulatory battles, and extremely difficult engineering challenges lie ahead, the direction has already been set. The era in which the sky belonged only to giant soulless machines is coming to an end. We are standing on the threshold of an age in which humanity itself will finally gain wings. Despite the fact that the very concept of personal flight feels as though it has been lifted straight from the pages of science fiction, the true revolution that the potential alliance between SpaceX and Gravity Industries is preparing goes far deeper than the creation of a new expensive toy for the technological elite. To understand the full scale of the coming changes, we need to look inside the same closed laboratories in Boca Chica and research centers in the United Kingdom, from which, according to insiders, the first technical details of a project already circulating in narrow circles under the codename Project Icarus are beginning to leak. The main technological breakthrough that SpaceX could bring to Richard Browning's work is connected to a fundamental rethinking of materials science. Until today, gravity's main problem has been the relationship between structural weight and thrust output. The latest insider reports published this week by the specialized outlet Spaceflight Now indicate that SpaceX's metallurgy division has proposed using a unique ultralight alloy based on lithium and aluminum with the addition of carbon nanotubes for the frame of the new suit, the same material being developed for the internal bulkheads of the next-generation Starship colonization vessel. This alloy has a specific strength 3 times higher than titanium, while its weight is comparable to dense plastic. The use of such materials would reduce the dry weight of the exosuit to just 14 kilograms. A person wearing it would barely feel any additional load, effectively solving the pilot's fatigue problem. The second, equally important aspect widely discussed by experts in Wired and The Verge is how the noise problem will be addressed. Gravity Industries' kerosene turbines roar at around 120 decibels, making them completely unsuitable for urban environments, as such flight would inevitably cause panic and deafen people on the ground. SpaceX engineers, drawing on their extensive experience in gas dynamics modeling and thrust vector control, are reportedly working on enclosed microturbines with active noise cancellation technology and variable exhaust nozzle geometry. By introducing specially shaped vortex chambers and piezoelectric mufflers, the frequency of the operating system could theoretically be shifted into the ultrasonic range, inaudible to the human ear. In practice, this would mean that a person flying overhead at an altitude of 30 meters would produce a sound no louder than a typical household drone or the whisper of Tesla electric vehicle tires on the road. But how would this device reshape global geopolitics and macroeconomics once it reaches mass production? Analytical centers are already modeling scenarios, and they appear staggering. The first major shift would occur in the structure of the real estate market. For the past century, property and housing prices have been determined by a single dominant factor: transport accessibility, proximity to metro stations or central highways. With the advent of personal flight suits, the concept of a prime location would be completely transformed. Land within a radius of 150 to 200 kilometers from major metropolitan areas, previously considered remote countryside due to impractical commuting distances, would instantly surge in value. A massive construction boom would begin in environmentally clean regions, at the foothills of mountains, on lake shores, in forested areas. Humanity would begin to spread more evenly across the planet, reducing pressure on overcrowded megacities and potentially driving down housing prices in the overvalued urban cores of New York, Tokyo, or London. At the same time, a parallel collapse would begin in the traditional public transport industry and the conventional automotive sector as we currently know them. Why buy an expensive-to-maintain car, spend money on insurance, parking, tire replacement, and sit in multi-kilometer traffic jams when, for the same money, you could purchase a compact personal suit that is stored in a regular closet in your hallway and charged from a standard wall socket? Yes, cars will remain for transporting heavy cargo and for long-distance travel in bad weather, but urban traffic would shrink dramatically. Highways that were once expanded to 12 lanes would gradually be narrowed, freeing up space for green parks, pedestrian zones, and open public areas. Cities would finally belong to people again, not cars. However, as the Wall Street Journal correctly notes, this coin has an extremely dark and dangerous side that is already giving defense ministers around the world gray hair. This concerns the complete restructuring of military tactics and national security concepts. Imagine a special forces unit where each soldier is equipped with a modified version of the SpaceX gravity suit featuring radar stealth elements. Such units would be capable of bypassing any air defense systems designed to detect large objects like aircraft or helicopters. They could silently penetrate deep into enemy territory at extremely low altitude, following terrain contours, conduct rapid sabotage operations, and instantly extract themselves. This would completely devalue the concept of traditional fortified borders, minefields, and high barriers. Any point on Earth would become vulnerable to sudden precision strikes. Moreover, there would arise a massive threat of a black market and technological terrorism. If such suits become widespread, criminal syndicates and radical groups would inevitably attempt to acquire them. A thief in a flying suit capable of reaching a penthouse balcony in seconds, stealing valuables, and disappearing into the night sky at 200 kilometers per hour would be a nightmare for law enforcement agencies. Public security police would have to be completely restructured. Traditional patrol cars would be replaced by elite airborne police units. Interceptors using similar high-tech suits equipped with electromagnetic pulse weapons capable of remotely disabling attackers' electronics and forcibly triggering their emergency parachutes. That is why, according to insiders in Washington, the White House administration has already initiated the creation of a secret interagency commission involving representatives of the Pentagon, the FAA, U.S. Cyber Command, and the Department of Homeland Security.